All right, here we are. We're back again, and basically we're finishing up on the different groups of the periodic table. We've been talking primarily about our two main groups. We have over here we have all the metals, and over here we have the non-metals. Non-metals, there are not as many of them, but that means they actually show up more often because these metals all have to combine usually with these non-metals, and so especially oxygen, sulfur, phosphorus, nitrogen, chlorine, bromine, a lot of these will show up again and again and be very common, because there's not as many choices for the metals to combine with. But anyhow, going back to metals, we said basically are very good conductors of heat. They are very good conductors of heat, also of electricity. Okay, and this has to do with the fact that they have electrons and they let go of their electrons, and so those electrons can move because of heat or because they carry electric current, which is of course the movement of the electrons. All right. They are also what we call ductile. Ductile means that they can be drawn into wires, long shapes like wires. Of course, we know we have electric wiring, with copper being one of the most common ones of those, but others can be used. The gold and silver are extremely good conductors, but they are expensive, so they're only used for very small things. Metals are also malleable. All right, I think the word mallet or hammer basically means they can be hammered out into sheets. Okay, so we can make sheets. So metals tend to stick together, and we can flatten them out into sheets. We can pull them into wires. We can make different shapes with them like that. And they're usually solids, although not all. There are some exceptions to that. Mercury, for example. Gallium is one that's very rare, but can be made. And gallium will actually, if you have a solid and you hold a test tube of it, it would start to melt. Basically, your body temperature would be enough to melt it. So very interesting there. But those are basically metals. Now, the characteristics of non-metals, on the other hand, are basically they're not all those things. It's probably the easiest way to say. Basically, non-metals are poor conductors. Okay, they don't conduct heat very well. They don't conduct electricity. Okay, so they're very poor conductors. All right, so you don't want them running your train because they're not good conductors. All right, they're usually, if some of them are solids, but they tend to be brittle solids. They can't be flattened out into things. They just crumple up if you were to put pressure on them. Some of them are liquids. We have bromine, which is a liquid. Okay, but a lot of them are gases. Okay, nitrogen, oxygen are the two main gases that we breathe. Okay. And so forth. So some of them are gases, some are solids, but they're very brittle solids and so forth like that. Now, interesting, hydrogen has some characteristics of metals and non-metals. You see it over here. You will also see hydrogen sometimes put over here because hydrogen can act like a metal or a non-metal. It is a gas, which makes it more like a non-metal. However, it also has a charge, a positive charge very often, which is like a metal. So it's kind of stuck on both sides. And so generally we think of hydrogen as a non-metallic gas if it's at room temperature. Okay. On the other hand, for example, we believe that the interior of Jupiter, and it has such a large planet and large mass, that hydrogen may exist as a liquid metal inside of Jupiter, we believe. But anyhow, that's obviously not the kind of conditions we would have on Earth here. But even on Earth, it can be a positive charge, which makes it fit with this group right here, because they all have a positive one charge. But it can also act like a negative one charge. And so sometimes you'll see a periodic table that draws it in both places, just to show that it's kind of schizophrenic there. It's a little bit metallish and a little bit non-metallish. All right. And we talked about last time, we said we have this non-metal or metalloid on the stair step here. Okay, some exceptions to that. Aluminum, even though it's right there, is still considered a metal. Okay, and so forth. But most of these that touch the stair step are considered metalloids. Okay, and so metalloids are elements that lie between the metals and the non-metals, and they have some characteristics of metals and some characteristics of non-metals. The main ones that are considered metalloids are boron, silicon, germanium, arsenic, antimony, and tellurium. Okay, Now, aluminum, polonium, and actinium are not necessarily considered metalloids, but that's not a big deal. Aluminum is about the only one that's very common that we talk about that's still considered a metal. So they don't conduct heat and electricity very good. However, some of them are very important because they are known as semiconductors. And semiconductors are used in computer chips and so forth. And they're very important because they can be used to turn on and off electric circuits. And they're very important to making circuits. Okay. Gallium arsenide, which has arsenic, which notice is one of those nonmetals, is extremely good semiconductor, okay, and can be used to make those circuits and things like that. So these are important as semiconductors. Okay, that can be a good thing. They can be turned kind of on or off and carry circuits, and so that's an important characteristic. But basically, metalloids are metalloid means metal-like. They're like metals, but they're kind of like non-metals. They're kind of weak in between, sitting on the fence, can't decide which way they're going to go. Okay, all right. Now, a couple other things real quickly before we go on. The groups on the periodic table are all of the columns. All right, so if we have these columns that go up and down here, that would be the group 1 or group 2 and group 3, group 4, 5, 6, 7, 8, 9, 10, all the way up to group number 18. So there's 18 different columns going across, and these are known as groups, or sometimes they're also known as families. So groups or families of elements, all right, would be the up and down columns, all right, of the periodic table. On the other hand, the horizontal rows are called periods. And so the first row has hydrogen and helium on it, and that would be the first period. Second period would have 8 elements on it, starting with lithium, ending in with neon. Third would have 8. Fourth would have 18, and the fifth would have 18. The sixth would actually have 18 plus these down here. So this row would go right there on the 6th period, okay? And the 7th period would contain this one down here at the bottom, okay? All right, so notice to be more properly, correctly drawn, this is what the periodic table would look like. These 2 rows down here at the bottom that we normally see up here, these 2 rows would actually be inserted right here on the 6th and 7th period, okay? And it would make it much longer. Why do they not usually draw a periodic table like that? It's very simple. Basically, it doesn't fit on a sheet of paper very well. Okay, so instead we take out these 2 rows, okay, and stick them down below it, and that's why we get the more familiar periodic table with these 2 rows down here. But just keep in mind, these 2 rows would belong right up here in period 6 and period 7. So there are 7 periods and 18 groups that make up the periodic table as we know it today. Okay. Now, someone says, oh, well, say we just had these 90, 80 elements. How do people decide to put it into a periodic table? Well, the idea of periodic is repeating. Okay, something that repeats on a regular basis is a period. Okay, so a period is just something that repeats. And in this case, certain characteristics start repeating. And it turns out that all the elements in this first group have similar characteristics to each other. And the ones that are in this group have same characteristics. So basically they start off with size. This has 1 proton, 2 protons, 3 protons, 4 protons, 5 protons, and so forth. And they notice that if you lined them up, every so often certain things had the same characteristics. And they put those same groups stacked up. And so that's a repeating pattern over and over, and that's why we have the periodic table the way we do. Okay, so basically groups or families have characteristics in common. For example, all the ones in this first group have a +1 charge. That's why hydrogen is over here. +2, all the ones in this column have that. Now the middle ones here are called the transition metals. Okay, the transition metals are all metals, but they have some changes in them, and it has to do with their atomic structure we're not going to get into. Then over here we have +3, ±4, and so forth. Okay, and then we start getting negative ones like -3 and then -2 and so forth. Okay, and so all these groups have characteristics in common. Okay, and that's why they're put in the same columns. On the period, on the other hand, as you go across the period, you're going from strong metals to non-metals, and so they tend to change as you go across. Okay, and they do not have the same characteristics as you go across the period. One of the examples of a characteristic that changes as you go across is the radius of the atoms. The radius means how far across or how much space they take up. Okay, all the ones in the second period, for example, would have protons in the middle, and they would have two electron shells around them. Okay, their first one would have 2. Okay, and so if you did lithium, for example, lithium would have 3 protons, and it would have 1 electron out here. Okay, but if you went over here to the other side to neon, neon would have 10 protons. Okay, it would still have just 2 shells. All right. All right, but because you have only 3 protons pulling the electrons here, it tends to be a bigger atom. As you come over here, you have the same distance away, these 10 negative electrons, but you have a positive 10 force pulling them in, so they actually take up less space and have a smaller radius. Okay, and the same thing trend you can see on each of the rings. These all have 3 layers, but by the time you get to argon, it has 18 versus 11 protons pulling all those 2 layers, so they get closer together. Okay, and you can see that trend for the most part continues. There are a few exceptions here and there, and that gets kind of complicated to explain all that, but we're not going to get into that. But basically, as you see, the radius tends to get smaller as you get across because you have the same number of electron shells or layers, and you have a bigger protons in the middle as you go across, so it starts pulling it in closer. All right. Another characteristic is electronegativity. So what on earth is that? Okay. Sometimes we just call it EN for short. Okay. And electronegativity, as you might guess, has something to do with electrons. Okay. And it has to do with how strongly atoms hang on to their electrons. Okay. So, for example, if you start over here at the metals, except for hydrogen. Once again, hydrogen acts kind of like a non-metal in this case, and it really would fit better over here by the helium. All right, they have a low electronegativity. This means they're like parents who take their kid to the park and just kind of don't really watch them. They just kind of let them run around and do whatever, and as long as there's the right number of kids around, they're happy with that. Okay, they don't really hang on to their electrons very well, and so the very smallest one down here in the corner is francium, but all the metals are fairly low. They do not hang on to their electrons very good. As you go across the period, they get to where they hang on to them more and more and more, and finally get to the non-metals and the inert gases here on the end we'll talk about in a minute, and they really hang on to their electrons. And so that's electronegativity, and this will be important when we talk about when they react with each other. You have metals who want to give away their electrons, and you have non-metals who want to hang on to electrons, and so they just rip the electrons away from the metals, and that makes the metals positive. It makes these negative, and that's part of what makes them react or stick together, because the difference in how much they want to hang on to their electrons. All right, and so that is electronegativity, and that's another thing that changes as you go across the period. Low electronegativity here, high electronegativity over here on the non-metal side. All right, in the next video we will talk about the groups, what the names of the different groups are, and some of their characteristics, and then we'll be finished with the periodic table. But once again, remember there's lots of information on the periodic table, and just by knowing where something is on the periodic table, you can tell if it's going to hang on to electrons, if it's going to lose them, whether it has a big radius or a small radius, how many protons it has, how many electrons, what does the atom look like, and some of those characteristics. But on to the groups in the next video.